Good morning, all of you. Welcome to Sri Jayendra Rank Zone. In the previous lecture, we have completed ionic equilibrium. Now we are going to start new topic in 11th class, that is S block elements. This will come under inorganic chemistry. Till now, so far we have completed organic chemistry. Now we are going to start inorganic chemistry. So let us start with this. So in the inorganic chemistry part, first chapter we have, that is S block elements. S block elements. Let us see the introduction. In this chapter, we are going to learn about the physical properties, general properties, and the chemical properties and uses of S block elements. So, what are the elements we have in S block? We are going to discuss now. So, what are S block elements? If the differentiating electron is what? The valence electron is called what? Valence electron. If the valency electron, that is the outermost electron, enters into S subshell of outermost shell, this is then those elements are called S block elements. The S block elements constitutes of two groups mainly, group 1 and group 2. The group 1 elements are known as alkali metals and group 2 elements are known as alkaline earth metals. Why these are called alkali metals? These elements are so called because their oxides and hydroxides are alkaline in nature, that is basic in nature, soluble base. We can say soluble bases are nothing but alkalis, soluble bases. And the metal oxides are found in its crust. So the oxides and the hydroxides are alkaline in nature, that is soluble bases, and the metal oxides are found in earth's crust. That's why these are called alkali metals and alkaline earth metals. So the metal oxides of this group are found in earth's crust. So that's why they are called as alkali metals and alkaline earth metals. So what are S block elements? If the differentiating electron or the valence electron enters into S subshell of outermost shell, those are called as S block elements. The S block constitutes only two groups mainly, group 1 and group 2. So group 1 metals are called as alkali metals and group 2 metals are called as alkaline. Next, among alkali metals, so what are the alkali metals we have? Lithium, sodium, potassium. Sodium and potassium are abundant, and lithium, rubidium, and cesium has lower abundance. Abundance means what? Availability. Abundance means what? Availability. So, among all the alkali metals, sodium and potassium are present in more concentration when compared to lithium, rubidium, and cesium have their lower abundance. Francium is radioactive and its half-life is only 21 minutes only. So francium is radioactive. This is also considered as alkali metal. So among alkali earth metals, calcium and magnesium are more abundant. You can see calcium and magnesium salts in the form of the salts in nature, while strontium, barium have very low natural abundance. Abundance, as I told you, availability. Radium is radioactive and is rarely found in nature. So radium is highly radioactive and it is rarely found in nature. So radium is a radioactive element of alkali earth metal. Francium is a radioactive element of alkali earth metal. So in alkali earth metals, we have one radioactive element. In alkali earth metals also, we have one radioactive element. Next. So what are the elements of first group metals? Nothing but lithium, symbol is Li, sodium, potassium, rubidium, cesium, and francium. So these are the elements present in the first group metals, first group elements. So group 1 elements are nothing but lithium, sodium, potassium, rubidium, cesium, and francium. What is the atomic number of lithium? 3, sodium 11, potassium 19, rubidium 37, cesium 55, and francium is radioactive and it is 87. And atomic mass 6.94, that is almost 7. This is 23, 22.99 means 23, 39, 85.547. These are the atomic masses. And francium is 223. And ionization enthalpy, the energy required to remove the valence electron, is called ionization enthalpy. So the ionization enthalpy is equal to, for lithium it is more. As we go down the group, the ionization energy decreases, you can see here. So lithium it is more because it is very close to the electron. The outermost electron is very close to nucleus. So more, because the atomic number of lithium is only 3. So as more amount of energy is required to remove the electron. So the ionization enthalpy for 1 mole to remove one electron from the outermost shell of lithium atom is 520 kilojoules per mole. And for sodium it is 496, and for potassium it is 419, rubidium 403, 376. So as we go down the group, ionization enthalpy decreases. These are the general trends. So what are the elements present in first group metals? Lithium, sodium, potassium, rubidium, cesium, and francium. And very important is all are metals. All are highly electropositive metals. Highly electropositive metals. All are highly electropositive metals. Next continuation. So next property, hydration enthalpy. Hydration enthalpy is minus 506, minus 406, minus 330, minus 310, minus 276. So due to this, what happens? All these metal oxides or metal hydroxides are soluble in water. All the metal oxides and hydroxides are soluble in water because their hydration enthalpy is in negative. The hydration enthalpy is negative. So they are very much soluble in water. They are very much soluble in water. So the compounds of lithium, sodium, potassium, rubidium, cesium are highly soluble in water as their hydration enthalpy is negative. Next, metallic nature. So lithium is less metallic when compared to sodium. Potassium is more metallic than sodium, then rubidium, then cesium. So cesium is the highest electropositive element in the periodic table. I'll write here. Cesium is the cesium is the highest electropositive metal. Highest electropositive metal in the periodic table. Highly metallic in nature. So ionic radius 76, 102, 138, 152, 167. So as we go down the group, ionic radius increases as the atomic radius also increases. Ionic radius increases. For francium, it is equal to 180. Next, we'll proceed to the next slide. Melting point, boiling point density. So melting point, lithium 454, 371, 336, 312, 302. So as we go down the group, the melting point decreases and boiling point, as these are all metals, they are present in solids, so they have melting point as well as boiling points. The boiling point is high. So, and as we go down the group, the boiling point also decreases, that is 1615 kelvins, 1156 kelvins for sodium, 103.2, actually this is 1000.32, 1032, actually there is no point here, this is 1032, and 961, 944, yeah, 1032, this is called 1032 kelvins. So there is all the alkyl metals have high boiling points and melting points as they are solids at room temperature, as they are solids at room temperature, as they are solids at room temperature, have high melting points and boiling points, high melting points and also boiling points. So please make a note of it. Next, density 0.53, 0.97, 0.86, 1.53, 1.90. So as we go down the group, the density increases. Density increases. Next, electron volt, that is electrode potential. This is called E degree is called what? E degree is equal to electrode potential. This electrode potential we will be discussing in class 12. Just you have to remember what is electrode potential. So just see the values only, that's all. Now it is of no use. So it is minus 3.04, minus 2.74, 2.95, 2.90, 2.927. So that's lithium is the strongest reducing agent. Lithium ion is the strongest reducing agent. This point you have to remember. The strongest reducing agent among alkali metals is lithium, lithium ion. Next is sodium. Next is potassium. No, next potassium, next sodium, and the sodium is the least when compared to all. First lithium, next cesium, next we have next we have rubidium, next cesium, next potassium. Almost they are similar, but highest is lithium. Lithium plus is the strongest reducing agent. Please note down this point in the in the class work. Very important. Lithium ion is the strongest reducing agent. Lithium ion is the strongest reducing agent. Next continuation. General properties of group 1 elements. Now we'll see now. First we'll start with, as I told you, in groups we'll study it differently. First we'll study general physical properties, general chemical properties. Next we'll study preparation properties of any two of the compounds. So all these chapters will be studied in only one way of method of learning. So it's very easy. Just listen carefully. First, we have electronic configuration in general properties. General properties of group 1 elements. So that is alkali metals. We are discussing only alkali metals. We are not discussing about alkali earth metals First we'll discuss about alkali, then we'll go for alkaline. Electronic configuration. All alkali metals have their outermost configuration as NS1. It's very simple because you can see lithium, it is atomic number is 3. So it is 1s2, 2s1. So outermost electron configuration 2s1. For sodium, it is atomic number is 11. So it is 1s2, 2s2, 2s2, 2p6, 3s1. So outermost electron is ns1. So these elements tend to lose their outermost electron and retain a stable octet. So if it loses one electron, it becomes helium gas configuration. If a sodium ion also loses one electron, it becomes neon gas configuration. So that is inert gas configuration. So these elements tend to lose their outermost electron and attain stable octet state. Thus, these elements are highly electropositive and never found in free state in nature because they are highly electropositive and more reactive also. So that's why they are never found in free state in nature. They are found in nature in the form of their salts or oxides or hydroxides. So this is about electronic configuration. Next continuation. So what is the outermost electron configuration of first group metals? Ns1, where N is called principal quantum number. So for example, lithium, it is 2s1. Sodium, it is 3s1. Potassium, it is 4s1. Rubidium, it is 5s1. Cesium, 6s1. And francium, it is 7s1. So the outermost configuration, N value will increase from down the group. So N is equal to 3, 4, 5, 6, 7. So it is called as principal quantum number. So these elements tends to lose their outermost electron by giving some ionization energy, and after losing their outermost electron, they can attain stable octet. Next continuation. So electronic configuration of lithium, helium 2s1, neon 3s1, argon 4s1, krypton 5s1, cesium xenon 6s1, and francium radon 7s1. That's all. It's very simple. So nearest inert gas configuration, once they lose one electron, they can attain their nearest inert gas configuration. So if lithium loses one electron, it will attain helium gas configuration. If sodium loses one electron, it will attain neon group configuration. If potassium loses one electron, it will attain argon configuration. Similarly, if rubidium loses one electron, it will attain krypton configuration. Like this, it goes on. So this is called the electronic configuration of first group metals, that is alkali metals. Next, atomic and ionic radii. The atomic size of alkali metals is the largest in their respective period. Very, very important. The atomic size of alkali metals is the largest in their respective period. Means what? Across the period, what happens? The atomic size decreases. So always, every period, period means left to right check. And so every period starts with alkali metal. Every period starts with alkali method except first period with the alkali metal. with alkyl metal. And as we move from left to right, as we move from left to right across a period, left to right across a period, what happens? The atomic radius decreases because the atomic radius decreases. Why the atomic radius decreases? Because the electrons are added in the same subshell. Because the electrons are added in the same subshell. So due to which what happens? Due to which what happens? Every period, the atomic size of alkyl metals is the largest in the respective period. Because suppose if you see second period, second period element is what? First lithium, then beryllium. Beryllium atomic number is 4, lithium is 3. So NS2. NS2 means here. And next we have beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So if you see these elements, so 5, 6, 7, 8, 9, 10. So the electrons are adding in the same subshell. That is NS2, NP2, NP126. NP126. So same subshell means N value is same. So automatically it will come closer to the nucleus. As it comes closer to the nucleus, the outer electron is coming closer to nucleus, due to which what happens? Atomic size decreases. That's why as every period, since every period starts with alkyl metal, so alkyl metal is the largest in their respective period. The atomic size of alkyl metals is always the largest in their respective period. I hope you understood this point. Next, the ionic radii are less than the atomic radii of corresponding parent element. Always the ionic radii is always less than the atomic radii. Ionic radii means the distance between the center of the nucleus to the outermost electron of an ion. Means, for example, if you see here alkyl metal sodium, if you loses one electron, it becomes neon configuration. So neon configuration means automatically the size decreases. So that's why the ionic radii is always less than atomic radii. The ionic radii is always less than the atomic radii of corresponding parent element. The atomic radii and ionic radii increases as we go down the group. So within the group, what happens? The atomic radii and ionic radii increases, sorry, as because the atomic number increases, so extra shell is added down the group. So down the group, what happens? The atomic radii and ionic radii is always increasing, not only in this group, any group. So I hope you understood clearly. So please note down what I have written on the slides and even the slide points also, so that it is easy for you to understand. Next, continuation. Next, third property, ionization enthalpy, very, very important. So as the ionization, what is ionization enthalpy? The amount of energy required to remove the electron, the amount of energy required, since we are in 11th class, we have to define these definitions. The amount of energy required to remove an electron, to remove an electron from a neutral gaseous atom, from a neutral, isolated neutral gaseous atom. Isolated gaseous atom or neutral gas atom is called ionization enthalpy. So the ionization enthalpy of an alkyl metals is the lowest in their respective period. Yes, because as we move from left to right, the atomic radii decreases, so ionization energy increases. Atomic radius increases, ionization energy decreases. So ionization energy of alkyl metal is the lowest in their respective period. The ionization energy of alkyl metals decreases from lithium to cesium. As we go down the group, atomic radius increases and ionization enthalpy, because the distance from the center of the nucleus to the outermost electron is always increasing. As the distance increases, it's very easy to remove because it is out of nuclear attraction. So that valence electron is easy to remove. So that's why down the group, always in any group, not only in first group, second group, 13th group, 14th group, any group you take, always the ionization energy of, uh, of the elements decreases down the group. So we can say here the ionization energy of alkali metals decreases from lithium to cesium. So any group, the ionization enthalpy decreases down the group. Any group, the ionization enthalpy decreases down the group. Decreases down the group means as we go down the group, because for groups we'll see top to bottom and for period we'll see left to right. So that you have to remember. For a period we have to see left to right, and for a group we have to see top to bottom. As any group, what happens as we go down the group, the atomic radius increases, hence the ionization enthalpy decreases. Atomic radius increases and hence the ionization enthalpy decreases. So this is called ionization enthalpy. Next continuation. Hydration enthalpy. What is hydration enthalpy? The hydration of an ion depends on the charge density of the ion. Lithium ion, being the smallest ion, has a higher charge density. The hydration enthalpy is larger for lithium ion, and the hydration enthalpy of alkali metals decreases from lithium to cesium. This point is important. They will ask in the examination. So, what is the hydration enthalpy order? So, lithium is having highest hydration enthalpy, next sodium, next potassium, next rubidium, next cesium. As the extent of hydration is more for lithium ion, the ionic size of hydrated ions is in the order, ionic size also is in the order lithium ions greater than sodium ion, greater than potassium ion, greater than rubidium ion, greater than cesium ion. So in the examination entrance, they'll ask the orders. So which of the following is the correct order for hydration enthalpy? Which of the following is a right statement for hydration enthalpy? So they'll give all theoretical questions from these groups. So how to get questions, how to answer these questions? Definitely you have to remember these orders or you have to remember the reason. So here in inorganic chemistry, all the reasons are important. You should know for everything, you should know the valid reason. If you don't know the reason, you cannot apply the concept and you'll not remember also. So as the hydration enthalpy is larger for lithium ion, the hydration enthalpy of alkali metals decreases from lithium to cesium. Next continuation. Physical properties of alkali metals. So these are the general properties, general physical properties. Now, alkali metals are silvery white, soft and light metals. These are all are metals. First important point. All the elements in the first group are metals. And alkali metals are which color? Silvery white color, soft and light metals. These metals have lower density and the density increases from lithium to cesium. Potassium has lesser density than sodium as an exception. So what is the density order now? They'll ask the which of the following is correct order of the density. So related to property, first you have to see these metals have lower density and the density increases from lithium to cesium. So lithium less than potassium less than, sorry, potassium is K less than sodium less than rubidium less than cesium. This is the density order less than cesium. So please note on this, children. This is the density order for alkali earth metals. Potassium has lesser density than sodium as an exception. The melting points and boiling points of alkali metals are lesser due to weak metallic bonding. So with what bond they'll form together, that is metallic bonding. So the alkali metals and their salts impart characteristic colors to the flames. So for example, lithium, crimson red color. So let us discuss now the colors. That is also very important. So they impart color to the flame. This is due to excitation of why they impart color to the flame. This is due to the excitation of outermost electron to a higher energy level, and de-excitation of electrons emits radiation which will fall in the visible region. So as the electron goes up to highest energy level, then it starts falling down, and this they have this de-excitation of electrons emits radiation. While falling, they emit radiation in visible region. So the colors imparted by various alkali metals are given below. So you can see the colors. It's very, very important. They'll ask an exam. So what is the color of lithium flame? So they give color to the flame. So they impart color to the flame. So lithium is crimson red color. Sodium is golden yellow. Potassium is violet. Rubidium is red violet. Cesium is blue. So all these colors you have to remember. It's very, very important. So what is the which color that does lithium metal gives to the flame? It gives red, crimson red color. Which color does sodium atom gives to the flame? It gives golden yellow, violet, red violet, and blue. As francium is radioactive, we will not study about it. So this color, so alkali metals impart color to the flame. This is due to the excitation of outermost electron to a higher energy. As flame means it will give heat energy, so they will absorb the heat energy and goes to the outer. The electron will go to outermost shell. Then what happens? It starts falling down. Emits while falling down, it emits radiation in the visible region. It emits radiation in the visible region. So the colors imparted by various alkali metals are given below: so lithium, sodium, potassium, rubidium, and cesium. Next continuation. Now, chemical properties of alkali metals. What happens when alkali metals combines with air? So the alkali metals react with air to form oxides, which can further with moisture to form hydroxides, which reacts further with moisture to form hydroxides. Very, very important. So the alkali metals combines with air. Air means oxygen to form oxides, which can react. And in this, lithium is most important because lithium combines with air to form lithium oxide, as well as lithium also combines with nitrogen from the air and forms lithium nitride. Lithium nitride, Li3N. So lithium combines with nitrogen and forms lithium nitride. So here this is called lithium nitride. So lithium oxide, lithium nitride. And sodium combines with oxygen and forms sodium peroxide as well as sodium oxide. Potassium combines with oxygen and forms potassium superoxide. So as a result, the metal gets tarnished when exposed to air. So all alkali metals combines with air because they are highly reactive. As alkali metals are highly reactive, they combines with air to form oxides first, oxides, and as a result of this metal gets tarnished when exposed to air, which react with further with moisture to form hydroxide. Moisture means water from the air. So lithium forms monoxide first, lithium monoxide, sodium forms peroxide, and other alkali metals form superoxides. The oxygen state of alkali metals in these oxides is state is +1. Which alkali metals? Any alkali metal, the oxygen state is always +1. So what are the different types of oxides they'll form? We'll discuss later. So lithium alone not only forms with oxide, with oxygen it forms oxide, and also it combines with nitrogen in the air and forms lithium nitride, only metal. Remaining sodium, potassium, rubidium will not form. Sodium, potassium, rubidium, and cesium will not form this nitride. Only lithium will form. So please note down this difference. So this is nothing but reaction with air or oxygen. Next continuation. Reaction with air continued. The alkali metals are kept in kerosene oil. Why they are kept in kerosene oil? Because as they are highly reactive, when they exposed to air, they get established. Means they are getting converted into oxides. So that's why the alkali metals are kept in kerosene oil as they are very much reactive towards oxygen and moisture present in the air. So lithium reacts with nitrogen to form lithium nitride. Apart from this, lithium alone will react with nitrogen from the air and forms lithium nitride, while other alkali metals do not form nitride. So please note down this point, very, very important. Other alkali metals do not form nitride. From the air, it will not react with oxygen and nitrogen. The other alkali metals react with only oxygen from the air and form their respective oxides, peroxides, and superoxides. Next continuation. Reaction with water. Alkali metals, this M is called alkali metals, combines with water readily and forms alkali metal hydroxide along with hydrogen gas. So lithium reacts with water less vigorously while other alkali metals react violently with water. Violently with water. Sodium reacts violently with water and form their respective sodium hydroxide. This behavior of lithium is due to its small size and very high hydration energy. As lithium is having higher hydration enthalpy, so it will react with water less vigorously, while other alkali metals react violently with water. So this is called second chemical property. Next continuation. Reaction with water continued. Also, alkali metals reacts with compounds containing acidic hydrogen like alcohols, alkanes, etc. So this reaction is also important. This you'll find in organic chemistry. So ethyl alcohol combines with sodium and forms sodium ethoxide along with hydrogen gas. So alkali metals react with compounds containing acidic hydrogen. Here this is C2H5O minus H plus. So here H plus is there. That's why it's acidic hydrogen. And alkanes. Alkanes also contain acidic hydrogen. So alkynes, they combine directly with sodium acetylide. Sodium acetylide. Acetylide means from acetylene. So this is called sodium acetylide. Two molecules, two hydrogen atoms are removed and replaced with two sodium atoms. So that's why it is called sodium acetylide and hydrogen gas. So when alkali combines with water and other compounds and other acidic hydrogen atoms, they release hydrogen gas. They release what? Hydrogen gas. This is very, very important. Please note it down in your classwork. All these reactions which you are giving in the PPTs are most important. So please note down in your classwork. Next continuation. Reaction with hydrogen. So alkali metals combines with hydrogen readily. As we already know, alkali metals are highly reactive. So they combine with hydrogen readily and forms their respective hydrides. So all alkali metals combine with hydrogen and form their respective hydrides. Let us start with hydrides now. So their respective hydrides. Alkali metals reacts with hydrogen at 673 kelvins to form respective hydrides. Lithium reacts with hydrogen at 1073 kelvins. 1073 kelvins. The temperature is important here to form lithium hydride. The hydrates of alkali metals are ionic solids because when they dissolve in water, they form ions. So the ionic bond formation, ionic bond. So with high melting points. Electropositive character increases from lithium to cesium. Stability order is lithium hydride. The stability order is very, very important. Please note down. Definitely they'll ask which of the following is the correct stability order of alkali metal hydrides. So lithium hydride is more stable than sodium hydride. This is sodium hydride only. It is not NaOH. Sodium hydrate, it is only NaH. Please note it down. Potassium hydrate, rubidium hydrate, and cesium hydrate. So electropositive character increases from lithium to cesium as already we know. But stability order of hydrates is lithium hydrate is more stable than sodium hydrate, than potassium hydrate, than rubidium hydrate, than cesium hydrate. So all important. So please note it down. Next, continue. I'm giving enough time for you to note also. So please do it properly. Next, continuation. Reaction with halogens. All alkali metals readily combine with halogens. All alkali metals readily combine with halogens and form their respective halides. So all alkali metals readily combine with halogens and form their respective halides. So please here, you can see here, alkali metals react with halogens to form respective halides. The halides of alkali metals are ionic in nature. Example, sodium chloride. Sorry. However, the lithium halides, very important point to note down. Lithium halides show a predominant covalent character, while other halides are ionic in nature. This is due to high polarizing power of lithium ion. Due to the high polarizing power of lithium ion, lithium halides show covalent character. Among halides of the lithium, the covalent character is of the order lithium fluoride less than lithium chloride less than lithium bromide less than lithium iodide. For halide, solubility decreases from fluorine to iodine. So lithium fluoride is more soluble than lithium iodide. So due to increase in the lattice energy, hydration energy decreases from lithium halides to cesium halide, and hence solubility also decreases. So as the hydration energy decreases and lattice energy increases, solubility also decreases. So solubility, comma, hydration energy. Solubility depends upon hydration enthalpy as well as lattice enthalpy. Hydration enthalpy as well as lattice enthalpy. This we have discussed in ionic equilibrium. So if lattice enthalpy is more, so its solubility is less because lattice enthalpy is inversely proportional to solubility. If hydration enthalpy is more than lattice enthalpy, the substance is soluble. So same topic we have discussed in ionic equilibrium, which you have completed in the previous chapter. So due to increase in lattice energy, hydration energy decreases from lithium halides to cesium halides, and hence solubility also decreases. So please note down, this is very, very important. Next, continuation. Reducing nature. The alkali metals acts as a very good reducing agents as they possess low initial energy. All the metals acts as very good reducing agents as they possess low initial energy. What is the duty of reducing agent? For example, copper sulfate combined with sodium, 2 moles of sodium and forms sodium sulfate and copper. So what is happening here in this reaction? Sodium is displacing copper from its salt solution. Sodium is giving reduction to copper sulfate. So copper sulfate is being reduced to copper. So that is why they are called as good reducing agents. All the alkali metals are very good reducing agents, and lithium is the strongest reducing agent among all the alkali metals. Lithium is the strong. So as I told you, among all the alkali metals, lithium is the strongest reducing agent and sodium is least powerful reducing agent. But anyway, these are reducing agents only. The standard electrode potential values measure the reducing ability of alkali metals. As I told you, the standard electrode potential values, which I have shown you in the first slide, values measures the reducing ability of alkali metals. So it is very, very important. Please note down. Next continuation. Reducing nature. So lithium on gaining one electron forms lithium atom. Potassium ion on gaining one electron forms potassium and sodium. So these are the electrode potential values. As more the negative electrode potential value, more is the reducing power. More negative, more negative reduction potential value, reduction potential value, stronger is the reducing nature. Stronger is the reducing nature. So this statement you have to write in your classwork. Stronger is the reducing nature. So among all the alkali metals, which is the strongest reducing agent? Lithium. Next, sodium. Next potassium, next sodium, next rubidium, next cesium. The highest negative electrode potential value of lithium is due to its high hydration enthalpy because lithium is highly soluble in water. Due to high negative electrode potential values, alkali metals cannot be extracted by reduction of their compounds but obtained by the electrolysis of molten salts. So, alkali metals cannot be easily obtained by the reduction process, like in the case of copper, zinc also. For example, zinc sulfate combines with sodium and forms sodium sulfate and zinc. So sodium has a capacity to displace zinc also from its salt solution. So these metals can be reduced by the reduction method, but alkali metals, as they are highly electropositive nature, so they cannot be extracted by reduction of their compounds, but obtained by electrolysis of molten salts. Electrolysis. So usually alkali metals are prepared by the means of electrolysis of molten salts. Next continuation. Next, solutions in liquid ammonia. Alkali metals dissolve in liquid ammonia to give deep blue colored solution. Every alkali metal dissolves in liquid ammonia to give deep blue colored solution which can conduct electricity. The blue color is due to ammoniated electrons or solvated electrons. So the blue color is due to the formation of ammoniated electrons or solvated electrons. So for example, let us see alkali metal sodium combines with X plus 5 moles of ammonia and forms sodium ammonium complex taken X times plus charge plus number of electrons of ammonia taken Y times Y minus. So this is nothing but ammoniated electrons. What is this called? Ammoniated electrons. So this they'll ask in the examination. All the alkali metals, when they dissolve in water, then when they dissolve in liquid ammonia, forms deep blue color solution due to the formation of compound that is nothing but ammoniated electrons. What is it called? Ammoniated electrons. Due to the formation of ammoniated electrons, all the alkali metals will give deep blue color solution. So please note down this, very, very important. Next continuation. So note down, I'm giving time for you to note. Next continuation. they give deep blue color solution. Any alkali metal you take, they give deep blue color solution with respect to ammonia. As the concentration of metal increases, the solid electrons undergo pairing process. As the concentration of alkali metal is between 1 molarity and 3 molarity, phase separation occurs, that is bronze colored solution floats on the blue color solution formed previously. As the concentration is greater than 3 molarity, the solution acquires bronze color. So the bronze colored solution is diametric in nature. So more about this pairing of electrons we'll discuss in the case of ammonia. So however, what happens when alkali metal is dissolved in ammonia, liquid ammonia? They form deep blue color solution due to the formation of solvated electrons which are responsible for the conduction of electricity. Next continuation. Chemical properties of alkali metals. The solution of alkali metal in liquid ammonia is aromatic. Very, very important. Please note down this. The solution of alkali metals in ammonia is liquid ammonia is aromatic in nature. The solution liberates hydrogen gas very slowly with the formation of amide. What they'll form? They form amides. This is called amide. Amide means NaNH2, sodium amide. NaNH2, sodium amide. Lithium amide. So like this they'll form. So this is called amide. Sodium amide. Sodium amide. So the solution liberates hydrogen gas very slowly with the formation of amide. So this is M plus electron plus ammonia forms amide plus hydrogen gas. As the concentration of solution increases, the blue color changes to bronze color and the solution becomes diamagnetic. Very, very important. So when the ammoniated electrons becomes so as the concentration of solution increases, the blue color changes to bronze color and the solution becomes diamagnetic. Diamagnetic means no unpaired electrons. Weakly repelled by magnetic field. Paramagnetic means highly repelled by magnetic field, highly attracted towards magnetic field, and diamagnetic field means weakly attracted towards magnetic field. Next, use of alkali metals. Lithium is used to make alloys. Alloys means what? What are alloys? Alloys means nothing but combination of metals. Combination of two or more metals. Combination of two or more metals. Two or more metals in a fixed proportions are called as alloy in suitable proportions. In suitable proportions are called as what are they called? Alloys. Sorry. So lithium is used to make many alloys. It is used to make white metal with lead, aircrafts with aluminium. Lithium is used to make batteries. Lithium batteries already we know rechargeable batteries. Sodium is used to prepare sodium lead alloy, which is used in the preparation of anti-knock agents for petrol. What is anti-knock agent? Means burning of petrol. Liquid sodium means when you burn petrol, what happens? A lot of cracking sound will come. So to prevent that sound, we'll use sodium lead alloy so that unleaded petrol will say. So sodium is used to prepare sodium lead alloy, which is used preparation of anti-knock. When the petrol is burned, the sound will not come. So that is called anti-knock agents for petrol. Liquid sodium is used as coolant in nuclear reactor. Liquid sodium is used as coolant in nuclear reactor. Potassium has vital role in the biological world. Potassium has vital role in the biological world. Potassium hydroxide is used as absorbent for carbon dioxide. It is not absorbent, it is adsorbent. Adsorbent means which can prevail in the outer surface. So potassium hydroxide is used as an adsorbent for carbon dioxide. It can absorb carbon dioxide gas. So these are the main uses of alkali metals. Still we'll do more about it. Next continuation. Let us see now. When sodium is heated in air at 350 degrees C to form X. See, this is the questions we are going to expect in the examination. Sodium is heated strongly in air at 350 degrees to form X. X absorbs carbon dioxide and forms sodium carbonate. And Y? Which are the following is Y? So let us straight away we'll write the equation. When sodium gas combines, when sodium metal combines with air, it combines with oxygen and forms sodium oxide. This sodium monoxide which forms X. Sodium monoxide combines with carbon dioxide and forms sodium carbonate along with water. So sodium carbonate. So it is nothing but what? So it is giving hydrogen gas or oxygen gas along with. So what is the answer? It could be, you can see here, it is oxygen gas. Sodium carbonate plus oxygen gas, because carbonate will form again with oxygen gas. So this is nothing but option B. Like this question, simple question they will ask in the examination. Next question. Explain why is sodium less reactive than potassium? Why it is less reactive than potassium, even though as we go down the group, the reactivity decreases. So why the sodium is less reactive when compared to potassium? Because sodium sodium is less reactive than potassium due to its less polarizing power polarizing power and hydration enthalpy hydration enthalpy. So due to this only, sodium is less reactive than potassium. So please note down. Next continuation. What are S block elements? As we already know, lithium, sodium, potassium, rubidium, cesium, francium, and alkali earth metals. Alkali and alkali earth metals, because differentiating electron enters into S orbital. If the differentiating electron enters into S orbital, they are called as S block elements. What are S block elements? We have alkali and alkali earth metals. Very simple. Next continuation. The valence configuration of element is 4s1. Name the element. It is quite simple here. So we know lithium is 2s1. So sodium will be 3s1. So potassium will be 4s1. So answer is potassium. What is the answer? Potassium. Next question. Name the alkali element which exhibits photoelectric effect. Very, very important. So the alkali metal which exhibits photoelectric effect is, what is photoelectric effect? It is nothing but we have seen in the first chapter, that is what is the atomic structure. So what is photoelectric effect? The emission of photons when a light is hitting on the metallic surface. So alkali metal exhibiting photoelectric effect. Just think about it. Alkali metal exhibiting photoelectric effect. Photoelectric effect. So it can be potassium, rubidium, or cesium, anything. So we have to write one. So which alkali metal exhibiting photoelectric effect is nothing but cesium has ability to exhibit photoelectric effect. Cesium has lowest ionization enthalpy. Cesium has lowest ionization enthalpy. Cesium has lowest ionization enthalpy. Hence, it can exhibit photoelectric effect. Hence, it can exhibit because it has the ease to lose electron. Photoelectric effect. Photoelectric effect. What is photoelectric effect? When a light of certain frequency is incident on a metallic surface, it emits electrons. Electron starts ejecting out from the surface of the metal. So this is called surface of the metal, and this is called light. So when light of certain frequency is incidenting on a metallic surface, electron starts emitting out. Electrons emitting out. So this is nothing but what commonly called as photoelectric effect. So cesium has lowest ionization enthalpy, hence it can exhibit photoelectric effect. So the alkali element which exhibits photoelectric effect is cesium. Next question. So these are the important questions we have from this lecture, but still we'll discuss more questions right now. So let us start now. I'm sharing another screen for you so that these questions can be visible for you when you're preparing the class. So next question number 6, MCQs based on today's concept, that is first lecture concept. Which are the following compounds? Just note down. Question number 1. Select wrong statement. Select the incorrect statement. The incorrect statement among, sorry, among, no, about alkali metals. About alkali metals. Select the incorrect statement about alkali metals. Option 1, we have to select the incorrect statement. All forms amides. All alkali metals forms, all forms amides, that is MnH2. Which will form amides, we'll see. Next, second option, all form superoxides. All alkali metals forms superoxides. Third option, option 3, produces sodium amide. Sorry, all form nitrides. All forms, all alkali metals forms, among alkali metals, all forms nitrides. And fourth option, all forms, all alkali metals forms, all alkali metals forms, so this is all forms ionic hydrides. Ionic hydrides. So second option is wrong because all will not form superoxides, only potassium, rubidium, and cesium. Potassium, rubidium, cesium forms superoxides of like KO2. Superoxides form superoxides. Sodium and lithium cannot form superoxides. Potassium, rubidium, and cesium only alone forms superoxides like KO2, RbO2, and cesium-O2. Remaining alkali metals will not form superoxides. So second option is wrong. Next question. Question number 7. We'll discuss 3 to 4 questions, then we'll stop this class. Next lecture, we'll continue with other topics. Next, alkali metals. Alkali metals, this question is important. Alkali metals can be extracted from their salts. Alkali metals can be extracted from their salts. By first option, reduction with carbon. Second option, electrolysis of aqueous solution of their halides. Electrolysis of aqueous solutions. Aqueous means with water, of their halides like sodium chloride, potassium chloride, etc. Not only chlorides, bromides, iodides also. Next, third option, electrolysis of fused halides. Very, very important. Electrolysis of fused halides. Fused means without water. And fourth point, it is reduction with aluminium. So in what way we can reduce alkali metals from their salt solution? So reduction by aluminum. These are the 4 methods. This is very, very important question, children. Please listen carefully. So since alkali metals are highly reactive, I'll write the hint here for you so that you can understand it better. Since alkali metals are strong reducing agents, they can be extracted Only by the electrolysis of fused salts. Fused salt means without water. Only by the electrolysis of their fused salts. Electrolysis of their HEIF fused salts. So this is about alkali metals. So if you take aqueous solutions, what happens? Electrolysis by doing, they'll give H plus ions also, as well as OH minus ions, along with alkali metal, along with alkali salt, that is SO4 2 minus. For example, let us say sodium sulfate is electrolyzed. Aqueous solution of sodium sulfate is electrolyzed. So by preferential discharge, the sodium may not go. Our ultimate motto is to prepare sodium. So that's why electrolysis of fused halides is more important than aqueous solution. Only by the electrolysis of fused halides only alkali metals are prepared, can be extracted from this salt. So remember this point, very, very important. This question will come definitely. This type of questions are most important because it is based on concept-based question. Concept-based question. Next question. Question number 8. Which one of the alkali metal? Which one of the alkali metal? Which one of the alkali metal forms normal oxide? Only normal oxide. Normal oxide of type M2O. So option A, it is lithium. Option B, it is sodium. Option C, it is potassium. And option D, it is rubidium. So only normal oxide means lithium only, because sodium can form sodium oxide along with sodium peroxide also. Potassium and rubidium will form superoxides. So that's why only lithium will form. So this is the answer. This is the answer. So like these questions you will expect in the examination for objective entrance examinations. More questions we will discuss in the next lecture. So with this, I'm ending this session. Please listen carefully. All the properties, general properties and physical and chemical properties of alkali earth metals we have discussed in this session. Listen carefully. And what we have done, from these properties, you can solve so many questions. But my sincere request, you solve questions only after the end of the chapter, because all the questions will not give in the entrance exam books serially. That is according to topic wise. If they are given topic wise, easily you can do it. As many objective competitive books, we do not have topic wise. So better you complete this chapter, write all the important points in your classwork, read once, then you can start easily. Then you start doing entrance books easily, you'll get the answers. So with this, I'm ending this session. Thank you.